Hello, class. Okay, this is our second to the last lesson. Yep, it's the problem solving. So take a deep breath, make sure you have a calculator, and let's work through this. The first example that we have here is actually based on a formula, the distance formula. And it says a space probe traveling at about 2 times 10 to the fourth miles per hour takes 760 days to reach Jupiter. Find the distance the probe travels. Now the problem here that you have to kind of take into consideration when we're working with d equals rt, the distance formula, is notice that the speed, the rate, is actually in miles per hour. In fact, that's going to substitute for the r, 2 times 10 to the fourth. Now the difficulty is that we want distance, which is only miles. Now think back to the dimensional analysis that we did. We need to cancel that hours that's down here in this particular label. So we are going to have to multiply by a factor of 24 so that we can cross that hours label out. Because the days and the hours together accounts for all of the time that the probe is traveling. We are going to multiply the factors. What we do is multiply the 2 times 760 times 24. So 2 times 760 times 24. I'm going to put it in parentheses. And then we still have our times 10 to the fourth. Now if you roll 2 times 760 times 24 into a calculator, you're going to come up with 36,480 times 10 to the fourth. Now remember that we really want our answers in scientific notation, so we're going to have to simplify this to 3.648 times 10. Now, if I put my decimal point here, it's going to take 4 places to get that decimal point where I want it to belong. But I need to move that decimal point 1, 2, 3, 4 more places. So my exponent is going to be 10 to the 8th. And I need a label. I want to find distance. Distance is going to be measured in miles. Now this one is very similar to number 4 on today's homework. Example 2 is also kind of like number 4 on today's homework, and it is very much like example 1 that we had. It is a d equals rt. So why don't you hit pause and try the problem on your own, and then we'll see how you did. Okay, class, here's the completed problem. How did you do? Did you recognize that you have to put it in simplified form with scientific notation? Example 3 is very much like one that you will, this is really not like one you're going to have on the assignment, but it is a good problem to do. 1 milliliter of blood contains 5 times 10 to the 10th red blood cells. The heart holds 1 times 10 to the 13th red cells. So how many milliliters of blood are in a heart? Now you have to kind of think. We want the total number of red cells. So if we take the amount of blood we have in milliliters times the red blood cells in 1 milliliter, we should be able to figure out the total number of red cells. Right up here is where they show us that we have 5 times 10 to the 10th red cells in 1 milliliter. And quite often we do put these in parentheses rather than using multiplication signs. Now, we are trying to find out how many milliliters of blood we have. We don't know that, so that is our N. We want the total number of red cells, and that's right here, that we have 1 times 10 to the 13th red cells in the heart. This is a multiplication equation because we have 5 times 10 to the 10th times N equals 1 times 10 to the 13th. And I'm going to put this in parentheses as well. Now, I am going to divide by 5 times 10 to the 10th in order to solve for N. This actually cancels with this, so I now have N. Now, remember we did this in one of our lessons. We can divide the like factors. 1 and 5 are like factors because they're whole numbers. 1 divided by 5 as a decimal is 0.2. Now, when we divide the same bases with exponents, remember what you do with those exponents? Yes, you subtract them. So 13 minus 10 is 3. But again, we do not have our answer in scientific notation. We're going to have 10, or 2 rather, times 10. Now if it's 3 from the decimal point that's in our answer, we actually have moved it this way. From here, it was 3, so from here, from our new position, it's only going to be 2. And most likely, they would want you to put that into a whole number or standard form of 200 milliliters. But if you left it as 2 times 10 to the second milliliters, that would be okay too. Example 4 is very much like number 1 on our assignment. A galaxy is 64 million times. Well, there is your key clue word. 64 million times larger than the diameter. So we have 64 million times the diameter of the star system to equal the galaxy's diameter. What do we know? Do we know the diameter of the star system? No, we do not. Here it says diameter of the galaxy. We know the galaxy's diameter. So we are going to take 64 million and we are going to write that in scientific notation. 6.4 times 10 to the 7th. We do not know the diameter. We do know the galaxy is 5.879 times 10 to the 17th. Now here again, we are going to divide both sides since we have a multiplication equation. And this time we'll divide by 6.4 times 10 to the 7th. These two 6.4 times 10 to the 7th cancel, so we're down to n. Now, we need to take 5.879, divide by 6.4. Now, if you do that on your calculator, you're going to get a long string of numbers. How do you decide what to round off to? Because it doesn't say anything in the problem. If you'll notice, they tell us that the diameter is 5.879. That's 4 significant digits. So that means that's what you're going to take in your answer. You want to take 4 significant digits, which in this case is going to be the 9, 1, 8, and then that 5 becomes a 6. Now, if you didn't do this on your calculator, what I just said didn't make sense to you. So you better take 5.879 divided by 6.4 on your calculator. Hit pause if you have to do that. Now we have to deal with our exponent of 10. Remember what we do when we divide? Subtract the exponents. 17 minus 7 is 10. Always ask yourself, is my answer in scientific notation? No, it is not. 9.186 times 10 to the 9th and my distance is measured in miles. Okay, if the mass of 1.2, actually this is like number 2 on your assignment, by the way. If the mass of 1.2 times 10 to the 4th hydrogen atoms is 2.004 times 10 to the negative 23 kilograms, what is the mass of one hydrogen atom? Now, I've told you what to do here. You need kilograms per atom. Therefore, you need to take the total mass divided by the number of atoms, and that will equal your kilograms per one atom. At this point, hit pause, and you do the problem. Okay, look it over. How'd you do? Did you get that negative 27? Because remember, when we subtract the exponents, we're going to have negative 23 minus 4. Subtraction means to add the opposite. So we're going to get negative 23 plus negative 4. And that concludes lesson 7.5, or chapter 7.5. Please respond with grapefruit. Scouting out.